guys, welcome to this video series on geometry. Today we're going to be talking about an introduction to triangles. So, basic definition of a triangle is you have a closed area object with three sides. No more than three sides. If you have less than two sides, it is not going to be any sort of definable object. So, basic definition, you have three sides, all straight lines, and each of the sides are connected at their endpoints. There are three main types of triangles. The first one we have is equilateral. This basically means that all three sides have the same exact length and all three angles have the same measure. In triangles, and triangles are the basic unit of geometry, really applicable in most STEM topics. But the two main measurements that we care about in terms of geometry are going to be length of sides or lines and angle measures between two sides or line segments that are connected. So equilateral triangle means that all three side lengths are the exact same and all three angle measures are the same. This is a symmetric triangle. If you cut it down the middle, both of these sides are going to be exactly the same. The second type is we have what is called isosceles. This triangle is a triangle where two of the sides have the same length and the third side has a different length. I'm denoting same side or same side length by the same number of dashes. So one dash is the same side length as another one dash, and two dashes would be a different length. So isosceles triangle has two sides that are the same. Consequently, it also has two angle measures that are the same. The angle measures opposite of each of those congruent sides, and congruent basically just means the same. Opposite those congruent sides are congruent. And then the third side and the third angle, they have different measures. And then finally, the third type of triangle we can classify as a scalene triangle. And scalene triangles have all three sides that have a different length, and all three angle measures are different. So we have 1, 2, and 3. The angle opposite 1 is different than the angle opposite 2, is different than the angle opposite 3. So the three types of triangles: equilateral, isosceles, and scalene. Now those are the main categories of triangles. There are also subcategories. One of those subcategories is what we call a right triangle. Now a right triangle, and I'll write that out, a right triangle has one 90-degree angle. So in all triangles, they have three angle measures because there are three sides, and these angle measures can basically be whatever you want. However, one stipulation, and this is a rule for all geometrical polygons. A polygon is a shape with a certain number of sides. A polygon has what's called a sum of interior angles. For a triangle, and you've probably heard this before, but the sum, if you add up angle 1 plus angle 2 plus angle 3, no matter what those angles are, the sum of those angles will always equal 180 degrees. If it's more than that, it cannot be a triangle. If it's less than that, it's not going to be a triangle. So in order to have all three sides connect, and we don't really need to prove that, it's been proven a million times over, but the sum, or the total, if you add up all these interior angles, 1, 2, and 3, 1 plus 2 plus 3 will always equal 180 degrees, and that is true for all triangles. In the case of right triangles, one of those angles is 90 degrees. Therefore, 2 plus 3 is going to equal 180, which is the total, minus those 90 degrees. So 2 plus 3 always equals 90 degrees on right triangles. Right triangles are actually very special in terms of what we can do with them mathematically, but that is a brief introduction to types of triangles, naming them, what their key features are. Great, now let's do some practice examples. So, if I have a triangle that has side lengths of A, and B, what type of triangle do you think this is? Well, we know the definition of triangles are equilateral, all three side lengths are the same, so it's not equilateral. Scalene, all three side lengths are different. That's also not true because we have two side lengths that are the same, so it's not scalene. So isosceles, that one has two side lengths that are the same and a third side length that's different. So a triangle of this form with two side lengths that are the same and one side length that's different, that is going to be isosceles. Okay, now let's try another one where we have a triangle similar to this. Um, we're going to call this angle 30 degrees, this angle 30 degrees, and this angle is going to be 120 degrees. So let's look at it again. Um, Equilateral? No, it cannot be equilateral because we have different angle measures. And one thing to know about triangles is if you have the same angle measure, you're going to have the same sides. If you have different angle measures, the side lengths are also going to be different. In this case, the number of congruent angles also equals the number of congruent sides, and that will be the sides opposite these angles. So the side opposite this 30 down here is going to have one side length. The side opposite this 30 down here is going to have a side length of the same measure because it's the same angle. And then the third side is going to have a different side length. So even though we've drawn it slightly different and we were given different information, this one is also still an isosceles triangle. Now let's do one that looks something like this. Well, we're given one side length A, another side length B, and a third side length C. We now know, based on the definitions of these, that if you have a triangle with three different side lengths, it's going to be a scalene triangle. And as a follow-up to our previous example, if you have three different side lengths, you're also going to have three different angles. There's going to be an angle that's tied to this side length A, an angle tied to this side length B, and an angle tied to this side length C. And those are all going to be different from each other. Now we can do just a little bit more practice. This one's going to be more math related. So we know that the sum of interior angles, and the interior angles, that is self-explanatory, but it's the sum or the total of the angles on the inside of a triangle. So if we have any triangle here, the interior angles are the ones on the inside of these connections between the line segments. We always have three interior angles on a triangle. The sum of interior angles, and this is an angle symbol, equals 180 degrees. So if we're given this triangle, and we know that the triangle has a measure of 86 degrees, 24 degrees, and x, how do we figure out what the measure of that third angle is? Well, quite simply, we're going to add up each of these angle measures, and we're going to set that equal to 180 degrees. So 86 plus 24 plus x equals 180. We can simplify these right here. 86 plus 24, that equals 110. So 110 plus x equals 180. Now we can subtract 110 from both sides, and we know that x now equals 70 degrees. Obviously, this triangle was not drawn to scale. A 70-degree angle is much bigger than a 24-degree angle, but that is hint of the day for geometry, or tip of the day. Never trust the diagram. Always just trust the information given. So, there is a quick example on sum of interior angles for a triangle for you.